Hey everyone, this is Chris, and today I'm going to be starting a short series on component-based architecture. We're going to start off looking at the high-level concept. So, component-based architecture is a different way of thinking from your traditional game object model inside your game engine. Whereas a game object model system, you have a root game object, and every object that you have in your game will inherit from this object. A component-based system still has a game object, but it is just a container for a bunch of components, each with a discrete function or a task. So you end up with just a single game object, and depending on what components you apply, it can be different things. Whether it's a particle emitter, or a trigger, or a renderable mesh with animations. So some examples of components you can have, you can see on my screen here, a transform component, which just holds your basic local and world transforms, a renderer component, a collider component, and a script component. So these are just a few components. You can have a lot more, and I will be mentioning those over the course of this series. Alright, now let's look at the inner workings of the component class and the other example components I have. So this component class has three main fields. A game object, which is a reference to the game object that the component is associated with. A bool flag for is enabled, so if the component is enabled or not. And a name, which is not unique. It also has its constructors. It has two constructors, one which takes the string name of the component, and one just a default constructor. It has a deconstructor, obviously. And now let's get into the functions. So the first function here is the awake function. The awake function is called when the component is first created. And then we have a start function, which is called when it is added to a game object and that game object is started. So that happens when the game is actually running. So there's a difference between the two of those. Awake is where you will initialize variables, where start is where you'll set up anything that's specific to that game instance. And then we have a fixed update, which is useful for things like physics. It's only called after a fixed time step, which can be configured. The update, which is called every frame. And the late update, which is called after update, but still every frame. So it's useful for things, if you want to have a camera following a player, you can ensure that the camera will always 100% update after the player, and you'll get a nice smooth following camera. And the last thing we have here is destroy, which just cleans up the component. So that's it for the component class. Let's take a look at the other subclasses of this. So the real one here, the main one I use right now, is the transform, which just holds all the different matrices and vectors and quaternions for the position, rotation, and scale. So I have all my math classes down here, and this is just what I use for those. So what we have here is we have a direction. We have our local matrix. We have our model view matrix, our model view projection matrix, our position vector, our right vector, our rotation quaternion, our matrix scale, our vector for up, and our world matrix. Aside from that, for the methods, we just have virtual methods that come from the parent component. And there's nothing really special there. And that's it. In the renderer, we don't really have any, there's no fields in there because the renderer is just a special parent class that is used to determine if an object is renderable. So with that, all we have there is, the only thing we add there is we had a render function, which will be then turned into a virtual function and used in objects that have a renderable component. Again, same with the collider. The collider is basically just a base collider. There will be several types of colliders, like box collider, capsule collider, sphere collider, and mesh collider, and probably a terrain collider. So the collider, all the collider does is it holds a center, it holds a value for is colliding, and it holds a value if it's a trigger. So if it's a trigger, it won't actually have collision, it'll just have a trigger, which will be triggered when something enters it, something that also has a collider attached. So to support that in here, we have all the basic stuff that we have, and then we have a trigger enter, a trigger reside, and a trigger exit. And that's it for the collider. The script component is much the same. There isn't much in here right now. The only things it has in addition is it has a script name, which is just a string name to the script that it's going to run. And it has a register and unregister of that script, which are just empty functions for now that just will eventually register the script. Alright, let's take a look at the GameObject class now. So the GameObject class, it has a vector of children, which is just a vector of game objects, and this is just used for the scene hierarchy. We have a vector of components, and these are just pointers to the components. We have a string name, which is used for identification. We have a parent game object, so that every game object will have a game object parent. We have a tag, which is currently unused, but it'll probably be used for some sort of identification in the future. And we have a transform component pointer. So this is the most important one of all of those, because this is what defines where it is in the game world, and every game object will have a transform, no matter what. Now let's take a look at the functions. So we have a couple of self-explanatory functions. Add child, which just adds child game object. Add component, which adds a component to the game object. Create the object, initializes the object beyond what the constructor does. And destroying the game object destroys it before the deconstructor is called. We have find all children by name, which will search through all its children and find and return all children that match the name provided. And then we have find child by name, which will only return the first child it finds of that name, which is faster. So if you know you don't have more than one object of the same name as a child, you can use that and it'll be a lot faster on the return. We have find component by name, and this will return the first component that uses that name. And as I mentioned earlier, components are not unique names, so there is a possibility that there will be more than one of the same component in certain circumstances, although a lot of components actually can't be on the same game object twice because they would conflict with each other. And then we have find component by type, which actually looks for the type of the component and returns that. And then there will be some other functions in here which aren't implemented yet, which find component by name, or find all components by name, and find all components by type. And then lastly here we have the constructor, which just is the default constructor and a name. Now let's take a look at the scene graph. So this is basically just a very simple graph that just manages all the game objects. It's not optimized. It doesn't really actually do any processing at all. All it does is list the game objects in the scene. So we have a field for the children and of the scene graph, which are all game objects, and then we have a root game object which is automatically created when you create the scene graph, and its transform component is 0, 0, 0. This is a non-editable component. You can't edit this component, but it serves as to make sure that every game object will have a parent, because mroot is a special one and we will ignore it, but every child component of that will have this as a parent at one point on their hierarchy. So then for functions, we have add game object, we have destroy, which destroys the scene graph, we have get game object, which will return a game object by name, we have remove game object, which will remove a game object by its pointer reference or by its name. You have a choice. And then we just have our scene graph constructor. And that's it for the scene graph. Now we're just going to overview a couple of special supporting structures which are useful for the game, or used with the game objects and components. So these are comparers, and basically all they do is they hold a name value, they have a constructor, and they have an overloaded operator for the brackets, for the function operator rather. And so these just allow you to search for objects, and it's all encapsulated, so you're not writing the same code over and over again for searching. And again, the same with the component. It does the same thing, except it's only with components instead. Now let's take a look at the component manager. So the component manager is a singleton. So this instance here is the instance. It's a pointer to a component manager instance. Then we have a vector of components. And now after this, we have 3 integers which hold various things. We'll start off with this one down here. So this is the current size of the vector. And this is useful for resize the vector, because we always want to resize the vector before we need to, just a little bit. and resize it at opportune times for memory reasons. Next, we have the current component count. So this is the actual number of components in the component manager at that time. Then we have the component size, which is how big we want to increment it, the resize every time we run out of space. Down here we have a vector, which is just to render components. This is because render components, as I mentioned earlier, they have a render function. And polymorphism, you can't call a render function from component if component doesn't have a render function. And I didn't give it a render function because most components, except for render components, don't have a render and they don't need that overhead. Alright, now let's just take a look at overview of the functions we're going to have here. So we're going to have an add component. This is fairly self-explanatory. Same with clear. Clear just clears the component manager and frees up all the memory. We have our constructor and our deconstructor back here. We have create, which will set everything up for the component manager, and destroy, which will clear and destroy the component manager. We have bool exists, so this is if the component manager actually exists. That's part of the singleton implementation. We have our fixed updates, our render or update, our late update. So all those functions will go through and call each of the components. We have get instance, which is another one of the singleton here, and that's just to retrieve the instance. We have remove component from there, and we have remove component with game object. So what this will do is this will actually go through and only remove components from the list that are associated with that game object. And then we have resize components, which will resize the array. So that's it for the component manager. Now, there is one last thing before we go on. Right now, everything is pointers in this. Normally, eventually, the component manager will not rely on pointers, but for simplicity's sake right now, the component manager stores pointers. So we don't actually have cache coherency, except for pointer cache coherency. So it's not that efficient, but that's okay for now. Alright, so that's going to wrap up this first video here. In the next videos, we're going to be going through and actually implementing all of these classes in C++. So I'll see you then.